Hi, Sabina.
Hi.
Welcome to Asteroid Foundation TV on NEO-MAPP.
Yeah, welcome. Thank you.
Thanks for being with us. I have a couple of questions, starting off with the most basics. What do you do for NEO-MAPP?
So I'm a postdoc, which means that I'm a scientist and I do numerical simulations of impacts into asteroids.
Numerical simulations of impacts into asteroids.
Yeah.
Does that mean that you're actually creating something I can watch?
Yeah, so I actually sit in front of a computer and I look how an impact creates a crater on an asteroid. And then I can take those simulations and make nice movies with them and analyze the data.
That's
so we can
incredible.
actually see what happens without doing the real thing, so just on the computer.
That's absolutely amazing, and we're actually going to be seeing that in action soon, aren't we?
Yeah.
So what mission were you also part of coming up that is all related to impacting asteroids?
So I'm part of the DART mission, which is going to be launching very soon, actually, a bit more than a month. And I'm also part of the HERA mission, the European HERA mission, that is going to be launching in 2024.
And what is DART and HERA for our viewers?
Okay, so DART is this amazing mission that is going to send a spacecraft to impact an asteroid and see what happens. And this is a NASA mission. While HERA is the European Space Agency mission that is going to go to this impacted asteroid and see what happens. And that is going to happen several years after the DART mission makes the impact.
Absolutely amazing. And isn't it true that this is going to be one of the first asteroid collaborations between the European Space Agency and NASA?
Yeah, indeed. So this is an international collaboration, and that is very important because it means scientists from all over the world, they come together and they have this one goal to study what happens when we impact an asteroid and if we can deflect it.
That's absolutely incredible. So I'm curious, how did you get involved in computer simulations of asteroid impacts?
So I always liked space, because space is so amazing and it is so vast. And then because I liked space, I went to university and studied physics and astrophysics. And that's where I discovered asteroids. Asteroids are these very cool, basically large chunks of rock in space, and they can be so different. And just by studying one is not enough. You have to study all of them. They're all so different, and studying never finishes, and every time you find something amazing about them.
That's incredibly cool. And what is your favorite asteroid?
Oh, that's hard to tell. Of course, I like Dimorphos, which is where DART is going to go. I also like Psyche, which is like this super cool asteroid that currently is believed to be made out of metal. Vesta is super nice. It's cool. This is a very large asteroid.
There's
so many of them, exactly.
There's too many. So I think that for most of us, we just assume that asteroids are just a solid rock in space. But in reality, we're finding out that that's actually not true. That they're just like completely solid pieces of rock is not the case for all of them. Is that right?
So as I was saying, asteroids, they can be very, very different one from another. So you can have a solid block in space, indeed, but most of the asteroids, especially those that are closer to us, are actually asteroids that or solid blocks that have been already destroyed and then reaccumulated. So they are basically smaller chunks of rock that come together and they are held only by gravity.
That's amazing. And so how does that change things as far as us impacting them? The difference between impacting one that is a bit looser, or from what I've heard, these rubble piles, which I'd love for you to explain more,
Yes.
versus something that's a bit more solid.
So I'll start by saying what a rubble pile is. So rubble piles are these pieces of rock that are held together just by gravity. Like, for example, if you look at the beach and you get all of these rocks together, and in space you only have the gravity that is holding them together, so they're not connected by anything else, and that would be a rubber pile. And then when you have an object that is made of this, and you try to impact it, it can be very, very different from impacting a solid block. And that is because impact cratering is actually a very complex mechanism, and there is a lot of physics that goes on. You will have very high pressures, very high temperatures, and what the asteroid is made of influences what the effects of this impact can be.
So I think that it sounds so cool because it sounds like with every asteroid mission, we're actually finding out more about this. And with the latest OSIRIS-REx tag, I think that was extremely telling of how things might end up with us impacting an asteroid. Can you tell us a little bit more about what happened with that?
Yeah, so indeed with every single mission we find a bit more about asteroids. So recently we had what is called the SEI impact on Ryugu, which created a crater that was much larger than it was expected. And that is because we believe that on the surface of Ryugu the material is not consolidated, so it's basically like having sand. And yeah, we learned so much about asteroids from just this one experiment. And now when we're going to have the DART impact, which is another large-scale experiment really, like a large-scale experiment in space, we'll learn even more and we'll expand our knowledge with what happened when you impact something in space rather than in a laboratory.
Crazy, crazy. So for all of the young people out there who are interested in getting involved in this field, can you tell us a little bit more about how you arrived to studying what you are and what your journey was?
So I started by choosing physics and astrophysics at university. And after that, I guess it's just, one thing leads to another. You do a undergrad project, then you do a master, then a PhD, and then you just continue with that. But if you're like school level or primary school, high school, then just focus a bit more on those subjects that could be important, like maths. Math is very important, computing, physics, a bit of chemistry, and maybe even biology if you want to look for life on outer planets.
That's incredible. Well, thank you so much for taking the time today.
Yeah,
it's
thank you for having me.
Absolute pleasure getting to know you, and we're excited to see what happens with the NEO-MAPP project.
Thank you. Bye.
Bye.